advanced physics class. I'm NC Joshua. Today we'll be looking at current electricity. And first we'll be looking straight to what is current. The current is the rate of flow of charges through a cross-sectional area. Current is the rate of flow of charges through a cross-sectional area. So it means the flow of charges is what brings about electric current. So we said current is equal to charge over time. Now remember that charge is measured in coulombs. The sign for charge is coulombs, while that of time is seconds. So it means that the SI unit for current can be ampere or coulombs per seconds. Now take note, current is a fundamental quantity and current also is a scalar quantity. Take note of these two information, very important. Now take note of this, that the current flow per unit area in a conductor or in a wire is called current density. Take note of that. So it means that current density will be current over area, but energy density is energy over volume. Take note of that. Current density is current over area, but energy density is energy over volume. Now we have carriers of electrical charges. Now we have inventors. What are the charge carriers? Inventors are free electrons. What about in liquid? The charge carrier in liquids, just like electrolytes. These are liquids that conduct electricity. So the charge carriers are ions. What about in gases? The charge carriers are electrons and ions. Then what about in semiconductors, metalloids? The charge carriers are holes and electrons, where this as a whole is the positive, while electron is the negative. Now we move to component and simple circuits diagram so that you get acquainted with all of these diagrams when you see them as you use them as the class progresses. This is a cell with a positive and a negative terminal. When you now have more than one cell combined together, it gives us what we call a battery. So this is a battery. So this is more than one cell combined together. So this is a battery. Now we have, these are resistors, standard resistors. It can either be this symbol or this symbol. Now we have these as variable resistors, rheostats. These are variable resistors. This is a galvanometer. This is a voltmeter. This is an ammeter. And this is a switch or a key in a circuit. Now let's see resistance. What is resistance? It's an opposition to something. So we say resistance, this is the opposition to the flow of current in a conductor. Take note of this. Resistance is a scalar quantity. It is a derived quantity. And the SI unit for resistance is ohms. Ohms. And this is how we write it, ohms. The SI unit for resistance is ohms. Now, what are the factors that affect resistance? Number one, the nature of the conductor. Each conductor has its ability to either prevent the flow of current or assist the flow of current. For instance, we have conductors that offer a low resistance to the flow of current. Such kind of materials are referred to as conductors. So the nature of the conductor is important. The length of the conductor is important. The area of the conductor is important, and the temperature. What about the length? Now, the longer the wire, the more the resistance. So it means that resistance is directly proportional to the length of the wire. Then area or thickness of the wire or of the conductor. If you have a thick wire and a thin wire, take note of those two words. If I have a thick wire and a thin wire, the thickness here, this one has more area. This has more area, while this has less area. So now take note, a thick wire has more area, hence there will be more flow of current in a thick wire, and there will be less flow of current in a thin wire. So it means that a thin wire will show more opposition to current flow compared to a thick wire. So it means that resistance is inversely related to area. So the more the area, the lesser the resistance. So a thick wire has less resistance compared to a thin wire. So a thin wire has more resistance than a thick wire. So why? Because thickness talks about area, cross-sectional area of the wire. So it means that resistance is inversely proportional to area, but resistance is directly proportional to length. Now we can talk about temperature. What about temperature? When the temperature is high, the conductor has more resistance. Why? Because electrons are colliding with each other and it increases the resistance in the conductor. So all of these are factors that determines or affect the resistance of a wire. So from here, I cannot say that RO is equal to a constant called resistivity L times 1 over A. So we have resistance is equal to resistivity L over area. Now, what is R? What is this symbol here? This symbol equals resistivity. That's what it means, resistivity. So, now please take note of this. Resistance or resistance equals resistivity times L over A. So what is resistivity? Resistivity, which is a specific resistance, resistivity is equal to RA over L. So it means ohms meter square over meter. That's what resistivity will not be. Then what this cancel out this, we now have ohm meter. So the SI unit for resistivity is called ohms meter. Now please take note of this, it's very important. Note this is very important. The inverse, or let me put it this way, the reciprocal of resistance, is conductance. Take note of this. So it means 1 over R equals conductance. The reciprocal of resistance is conductance. Therefore, the SI units will be equal to the SI unit for conductance. Remember, the SI unit for resistance is ohms. So therefore, the SI unit for conductance will now be per ohms. Then also note again that the reciprocal of resistivity is called conductivity. So that means 1 over resistivity equals conductivity. So it means the SI unit for conductivity will not be the inverse of the SI unit for resistivity. Resistivity is ohm meter, so it will not be per ohms per meter. Take note of this. Now take note, also note that per ohm is called Siemens. Per ohm is called Siemens. So per ohm per meter will not be called Siemens per meter. Take note of this. Per ohm is what we call Siemens. Then per ohm per meter will not be Siemens per meter. Take note of this. This is very important. We'll be doing some questions to show this and how this can be solved. Now let's see if resistance equals resistivity L over A, and A, which is area of the wire, is equal to pi r square, where r equals diameter over 2, where radius equals diameter over 2. Therefore, what will be A? A will be equals diameter pi instead of pi r square, it can be pi d over 2, all in bracket square, which equals pi d square over 4. So therefore, what will now be resistance? Resistance will now be equal to resistivity L. Then now it will now be divided by, now what's our A? Our A is now pi d square over 4. So this will now be resistivity L times 4 over pi d square. So you know that you will now be having 4 pi L, 4 resistivity L over pi d square. So take note of this because it will be important. Some persons will just take it here and just do or and say PL over pi d square over 4. It can still be this, but this is what I brought here to now arrive at this particular answer. Now we'll be looking at some questions where we need this to solve. Okay, now let's see example 1. It says the specific resistance. Now take note, specific resistance is also called resistivity. The specific resistance of a wire is this. Its volume is 3 meters cube and its resistance is 3 ohms. Then its length will be dashed. Now, what's our formula for solving that? Resistance is equals resistivity L over A. We are given volume instead of area. Note, note that volume equals area times length. So therefore, 3 meters cube equals area times L. So what will not be our area? Area will not be equal to 3 over L. Take note of this. That will be our area. Then what's the next thing now? I'm looking for I'm looking for the length. So now I will say, what is length? The length will be equal to, from here, arrow A over resistivity, which is now equal to, what's our resistance? Our resistance is 3. That's this resistance of 3 ohms. So we'll now say is equal to 3 times, what's our area? Our area is 3 over L. That's our area. Then I like to do it this way for simplicity. Divide by, what's our resistivity? Our resistivity is this. That's what we have. So now what becomes my answer? Now this will not be equal to 3 times 3 over L times 1 over resistivity. So this will cancel out this. So L will be equal to, I will now have L is equal to 1 over L resistivity. Cross multiply this, we're going to be having L square resistivity equals 1. Therefore, L square equals 1 over resistivity. So L will now be equal to square root of 1 over square root of resistivity, which equals 1 over square root of resistivity. So the answer is either this or this. So this is also equal to square root of 1 over resistivity. That's the answer to this question. Now we'll be looking at the second question. Number 2 says the resistance of a wire of uniform diameter D and length L is R. So these were the first sentence of the question. The resistance of another wire of same material, take note of this, same material, meaning they have the same resistivity, the same nature of the material. So it means the resistivity of this first material and the second material are the same. So it means to solve this, I'll say resistivity of 1 equals resistivity of 2. Now, what is resistivity? Remember, we have, recall, we have arrow is equal to resistivity L over A. What's now resistivity in this formula? Resistivity will now be equal to arrow A over L. So if I put this into this case, it means I will have arrow 1, A1 over L1 is equal R2 A2 over L2. But remember, our question is having diameter. So it means I will not be solving with area. I have to convert to diameter. So it means I will not say R1 dot area will not be pi r square over L1 is equal to R2 dot pi r square over L2. Now recall that radius to diameter would be diameter divided by 2. So it means I will not come back here to say R1 dot R1 dot pi d square over that's diameter over 2 all in bracket square over L1 is equal to R2 dot pi d over 2 all in bracket square over L2. Take note of this. I have converted my areas to diameters. Now let's continue now. Come back to your question. We are told that the resistance of the other wire of the same material 2D. So it means that for the second diameter is twice that of the first diameter. Then we have the second length 4L is 4 times that of the first length. So I can say that note my D2 is equal to D1 and my L2 is equals 4D1. Take note of that. That's what our question said. So put this back into the equation. I will now have R1 dot pi D over 4, that's D square over 4, over L1, this is our 1, is equal to R2 dot pi 2D. 2D now, 2D over 2, all in bracket square, over 4L, because my L2 is 4L1. Take note of this, as my 2D is 2D1, as my D2 is 2D1. Look at it here. Now, so I will not say that to continue this, let this cancel out this, let this cancel out this, then I'll be having R1 dot D1 square over 4 is equals R2 dot 4D1 square over 4 all over 4. Now, if you check that very well, you see that this will cancel out this. Then we're now left with R1 dot. Let D1 square cancel out D1 square. So you have R1 over 4 is equal to R2 over 4. 4 cancel 4. Therefore, R1 equals R2. Take note of that. That becomes the answer. So the answer is this. That's the answer to that question. Now let's look at Ohm's laws. Ohm's law states that the flow of current through a metallic conductor, take note of this, through a metallic conductor is directly proportional to the potential difference across its ends. So it means that Ohm's law is only applicable to metallic conductors, metals precisely. Now this is the mathematical expression of Ohm's law. Voltage is proportional to current. Then we have V equals I arrow, where arrow is a constant called resistance, and resistance equals V over I. The SI unit for resistance is ohms. Now, this is a graph showing Ohm's law. Now, all these are graphs of Ohm's law. Now, look at this precisely. This is, let me take it off. This is an ohmic graph. So these graphs obey Ohm's law. So the slope is the resistance. So V over I. What about the alternative, which is now the inverse of this graph? We now have it as I to V, and we have it as conductance. Remember I said that the reciprocal of resistance is called conductance. Remember that. Now we have substances that do not obey Ohm's law graph. We call such substance non-ohmic substances, while substances that obey Ohm's law are called ohmic substances. An example of such substances are mentals. So why substances that do not obey Ohm's law are called non-ohmic. Example of such substances are gases, transistors, semiconductors, diodes, filament of lamps. All these are non-ohmic graphs. Take note of them. So non-ohmic substances are substances that do not obey Ohm's law, but metals are all substances that obey Ohm's law. Now let's look at resistors in the way they are connected. Number one is a series connection. Number two is a parallel connection. Now, how do you know it's a series connection? If a current is coming from here, the total current that is coming from here will enter into this resistor, still leaves here and come into this place. So I can boldly say that in series, the two resistors have same current, but they have different voltage. Take note of this. In series, they have same current, but in parallel, the current coming here is divided into here and here. Hence, they have different current, but in parallel, we have different current and we have same voltage. Take note of this. So now, what about in series? Let's see. So if they have the same current, if we have the same current, we'll say that V equals I arrow. What is the total voltage? V total in series, because they have different voltage, is equal to V1 plus V2. So therefore, if V equals I arrow, I will now have I arrow in terms of total is equal to I arrow in terms of 1 plus I arrow in terms of 2. Now remember, what do they have in common? They have the same current in common. So if I here are the same, it means I will have arrow T dot I is equal to I open bracket, I is common here, arrow 1 plus arrow 2. So I cancel that I now have my arrow total is equal to arrow 1 plus arrow 2. So anytime we have resistors connected in series, the effective resistance or the total resistance is calculated by arrow 1 plus arrow 2. So for instance, I have a circuit like this and I have resistors connected like this, resistors connected like this, then this is 1 ohms, this is 2 ohms, this is 3 ohms, and this is 4 ohms. It means that the same current that is coming from here will enter here, leave, enter here, leave, and enter here, leave, and enter here. So it means that this is a series connection. So my arrow total will be 1 plus 2 plus 3 plus 4, which is now 7, 8, 9, 10. So we have it as equal to 10 ohms. So this is a series connection, and when we have a series connection, you say arrow 1 plus arrow 2. Now this is a case of parallel connection. So the current coming here gets here and it divides. So this current will be I2 while this will be I1. So our total current is equal to I1 plus I2. Now look at this. If V equals I arrow according to Ohm's law, therefore current will now be voltage over arrow. So put this in place of this. I will now have V over arrow total equals V over arrow 1 plus V over R2. Remember, what do they have in common? They have same voltage but different currents. So therefore, if they have same voltage, means that this V equal to this V equal to this V. So I have 1 over R dot V is equal to V open bracket. The V here is common. So V open bracket 1 over R1 plus 1 over R2. So my V cancels out my V. I have 1 over R total is equal to 1 over R1 plus 1 over R2. So if you go further, what's the LCM of R1, R2? Is R1 dot R2. This takes of this, R2 times 1 is R2 plus this takes of this, R1 times 1 is R1. It equals 1 over RT. So therefore I have 1 over RT is equals R2 plus R1 over R1, R2. Therefore, what is now RT? RT is now R1, R2 over R2 plus R1. That's what we call product over sum. Product over sum. So this is how we arrange in parallel. So it means that in parallel, they have different currents, but they have the same voltage. So we'll be looking at various examples. So if I have a case like this now, and I have here to be 2 ohms, and I have here to be 3 ohms, and we are asked to find the total resistance. It will just be R total equals product over sum. So it will be 2 times 3 over 2 plus 3. That will be 6 over 5 ohms. That's the answer to that question. So we're looking at more examples in this case to show more light in this. Thank you. Now let's look at an example. Example 1, we are asked to calculate for the total or the effective resistance between X and Y. Now remember, these two are in parallel connected to this. So to solve this out, I will solve this out first, the parallel case of, then I will now have a new circuit, which will now be 3, and the answer to these two in parallel to now make it become series. Look at what I just said. Now, in solving this out, which is in parallel, we'll say total resistance is equals product over sum, which equals 2 times 2 over 2 plus 2, which is 4 over 4, which equals 1 ohm. So the effective resistance of this is 1 ohm. So my new circuit will not be this. This is not my new circuit. My new circuit is this X, Y. Here is 3 ohms. Y here is now 1 ohm. So these two has been solved to be 1 ohm. So now 3 and 1 are now in series. So therefore, my arrow total is now 3 plus 1, which equals 4 ohms. So the total resistance of this circuit is 4 ohms. Let's see another example, which is my example 2. Example 2. What about example 2? You look at the circuit. We are asked to find the effective resistance. So what will I do? I have to know which of them are in series and which of them are in parallel. Now you know that any current that enters here will definitely come here, will definitely come here. Just like any current that enters here will come here and will come here. So I can boldly say that from here down to here are in series. They are in series. So for series connection, what will I do for series connection? I have arrow total is equals 2 plus 2 plus 2. That's 2 plus 2 plus 2, which equals 6 ohms. So if here to here is 6 ohms because they are in series, what will now be my new circuit? My new circuit will now be this. My new circuit will be this, which I have here as 1 ohms. Then I have this place again, another 1 ohms. Now please take note of this, very important. Now I have here as 3 ohms. So this would be 3 ohms, 3 ohms. Then I have solved these 3 resistors to now become 6. So I'll do this part, and here is my 6 ohms. So you see the new circuit. So everything about here has been closed because it is in series to now become 6. So now this and this are in parallel, not in series. Because if a current is coming from here at this junction, it will divide here, while it will go this way. So 6 and 3 are in parallel, not in series. So to solve for the parallel, I will say arrow total equals product over sum. So arrow total is equals 3 times 6, 3 times 6 over 3 plus 6. So this will now become 18 over 9, which is now 2 ohms. So now I have solved this out to become 2 ohms. What is now my new circuit? My new circuit is now this with 1 ohms. Then I have this again with 1 ohms again. Now this one has been solved, compressed to just 2 ohms. Look at it here. To just 2 ohms. So now the circuit that started here went from here to here, now from here to here. Now if you now check it, every resistor here is now in series, no longer in parallel. So now our arrow total will now be 1 plus 2 plus 1. 1 plus 2 plus 1, which equals 4 ohms. So the total resistance of these resistors here is equal to 4 ohms. Now let's look at example 3. This one is a little bit more complex than the previous ones. It says calculate the current flow in the 12 ohms resistor. Now we have a 2 ohms resistor, 4 ohms resistor, 12 ohms resistor. Everything here is in parallel. They will now have it in series. So that's 6 ohm resistor. But remember that the voltage or the PD in the circuit is 12. Now what is the important basics that you know in this topic is that for resistors in parallel, they have same voltage but different current. But resistors in series, they have same current but different voltage. Now, if the total voltage in the circuit is 12, now the question is now, what is the total current in this circuit? To know the total current in this circuit is to add up the whole resistors, get the total resistors. Since we know the total voltage is 12, know the total resistance, then apply Ohm's law to get the total current. So let's know what is total current. So first, total current. Total current. What is total current equal to? I total is equal to V total over R total. So now let us now solve for R total because we have our total voltage as 12. We're looking for total current. So let's solve for the total resistor. So our total resistor, which is 1 over ROT. Now I'm solving this parallel first. 1 over ROT is equal to, what is it equal to? 1 over 2 plus 1 over 4 plus 1 over 12. If you are very skillful, the LCM of 2, 4, and 12 is 2 times 4 times 12. This cancels this. I'm left with 4 times 12. So I have 4 times 12 plus this cancel this. I have 2 times 12 plus 2 times 12 plus this cancel this. I have 2 times 4 plus 2 times 4. Everything is equal 1 over arrow total. So now what is now 1 over arrow total equal to? 1 over arrow total is now equal to 4 times 12. 4 times 12 is 48 plus 2 times 12 is 24 plus 2 times 4 is 8 over 2 times 4 times 12. So what do we now have now? Arrow 1 over arrow total is now equal to this plus this. You have 72. So 72 over 2 times 4 times 12. And that's what you have there. Please, sorry, 72 plus 8, that's 80. So we have here 80 over 2 times 4 times 12. So this takes out this is 4, this takes out this is 10. So I now have 10 over 12. So therefore, arrow total is now equals 12 over 10, which equals 1.2 ohms. So the total resistance in this parallel case is 1.2 ohms. So 1.2 plus 6, because this is in series to this O. So this 6 ohms is now will be in series to this. So it means I will now be having total resistance is now equals 6 plus 1.2. 6 plus 1.2 is equals 7.2 ohms. So that is the total resistance in that circuit, 7.2 ohms. So therefore, what is our total current? Total current is equal to total voltage over total resistance, which equals total voltage is 12, 12 over total resistance now is now 7.2. So IT is equals 1.67 ampere. So now I have solved for the total current. So it means that a current of 1.67 ampere comes and it enters into this place. It leaves this place, it comes here. So now 1.67, some fraction will go here, some fraction will go here, some fraction will go here. So our question is asking us, what fraction will come here? That's what our question is asking us. So now, since I know the total current that is coming here, please watch this. What about the total voltage? Now, remember, we know that when they are like this, they have the same voltage. So it means that the voltage here is 12. The total voltage in the circuit is 12. What is now the voltage here? And what will be the voltage here? Now let's see. I already know the current here because this is the current coming, 1.67. The current here will be 1.67. So now I can come to say, please pay attention. I can come to say voltage at 6. Voltage at 6, which is V is equals I arrow. V equals I arrow. So voltage at 6 is equal. What's the current at 6? 1.67 times. What's the resistance there? Is 6 ohms. So what will now be the voltage at 6? The voltage at 6 will now be equal to 10.02 volts. So it means that of these 12 volts, 10.02 is coming here alone. So the remainder from 12 is what is coming here. So therefore, uh, 12 volts minus 10.02 volts is equal to 1.98 volts. So this 1.98 volts is what is coming to all of this here. Remember, this one has 10.02. So the remaining 1.98 volts is what each of these resistors have. So if you add 1.98 plus 10.02, you have 12 volts, which was the total. So now, of these 12 volts, 10.02 is in the 6 ohms resistor. So the remaining 1.98 volts is the same for each of these circuits. So that means to now get the current in the 12 ohm capacity, the 12 ohms resistor, I will now say V is equal to I arrow. Therefore, I is equals V over R. So I for 12 will be equal to, what is the V? The common voltage each of them have, because in parallel, they have the same voltage, which is now 1.98 over, what is the resistance? The resistance is 12. What about for I2, which is this place? I2 is equal to, what is V? V again is this same number, because they have the same voltage. It's now 1.98 over, what is the resistance? The resistance is 2 over 2. What about for I5? Sorry, I4. The current in 4 will be equal to, they have the same voltage again, which is this 1.98, which is 1.98 over, what is now the resistance? The resistance is 4. Now, look at each of them now. The current in 12, the current in 2, the current in 4. Let's see if we add them together, it will give us the total current that was coming here. And remember, what was our total current? Look at the total current. So now let's see. So the answer here is now 0.165 ampere. So the current in this place is gotten by the voltage, total voltage that is coming here, over the resistor or the resistance of the circuit. So that's why you are seeing this 1.98 over 12. What is this 1.98? That's the total current that came here. 1.98 is our total current, sorry, our total voltage is 1.98, then our resistance is this. So this becomes our current. So try and do the others and let us see if you have an understanding of what we just did. So you can see the way I did for the I2, and you can see the way I did for the I4. So that's how you solve it. They have the same voltage, but they have different currents.